Hello everyone, today we want to talk about 8.5 partial fractions, the last part. So the materials on previous lecture notes about partial fraction decomposition assumes that f of x is a proper rational function. That means the degree of the numerator is less than the degree of the denominator. Okay, so if we have a proper rational function, we can perform partial fraction decompositions. Okay, and remember there are 4 different cases. When you have simple linear factors, repeated linear factors, simple irreducible quadratic factors, and repeated irreducible quadratic factors. Okay, so the question is, what if f of x is an improper rational function? Okay, so that means the degree of the numerator will be greater than or equal to the degree of the denominator. What should we do? For example, right here, you can see that we want to evaluate the integral of x to the fourth over x squared minus 1. Okay, so notice that this is an improper rational function because the degree of the numerator is 4, which is greater than the degree of the denominator, 2. Okay, and the answer is really easy, and basically you have seen this in high school. Okay, so you can treat this lecture as a review of what you have done in high school. Okay, and the answer is to use polynomial long division. Okay, to use polynomial long division to make it a proper rational function, and then we will perform partial fraction decomposition. Okay, so before we talk about this example, let's make a quick review. Okay, so let's say we have let's say we have 32 over 5. We want to divide 32 by 5. So we put the numerator right here. We want to divide 32 by 5. Okay, and then we have to find a number. So when I multiply by 5, it will reach, it will become as close as possible to 32, right? And we don't want to be greater than 32. So we will put a 6 right here. So that will give us 30. And we have 2, right? You have to use minus, right? Subtract 30 from 32, that's a 2. And we notice that this 2, okay, this number is less than 5, so we stop. Okay, now if this number is greater than 5, then you have to keep going. Okay, but this number is less than 5, we stop. Okay, and we call this the quotient, and we call this the remainder. So we can write 32 over 5 as the quotient, 6, plus the remainder over 5. Okay, so that's basically we did in like elementary school, right? Now we want to use the same idea. Okay, we want to use the same idea. So you can see that right here. After I use the division, this 2 over 5 is proper. Originally 32 over 5 is improper. Okay, but now it becomes proper. So that's the whole idea. Okay, that's the whole idea. So now I want to divide x to the fourth by x squared minus 1. Okay. Now one thing you need to be careful about is that when we perform polynomial long division, we like to fill in those missing terms. Okay, so what does that mean? Right here you have x squared minus 1, so we will put a 0x in between. Okay, so we will put x squared plus 0x minus 1 right here. And we want to divide by, we want to divide x to the fourth by x squared plus 0x minus 1. Okay, again, let me fill in the missing terms. 0x cubed, 0x squared, 0x, and 0. Okay, So we usually take a look at, when we perform polynomial long division, we take a look at the highest term. Okay, this is what we call a leading term. So x squared. So I want to multiply by x squared in order to get x to the fourth. So x squared times x squared is x to the fourth. And then 0x times x squared is 0x cubed. And I have minus 1 times x squared, that's a minus x squared. Okay, that's a minus x squared. Okay, so right here you can see that x, again, we want to use subtraction. So let me label this. This is subtraction. So x to the fourth minus x to the fourth, that's 0. 0x cubed minus 0x cubed, that's 0 again. 0x squared minus negative x squared. So I have a positive x squared. Okay, I have a positive x squared. Okay, so notice that since this is 0 and we have to multiply by 0x to make it 0. Okay, otherwise if you have something x, then you will have x cubed. Okay, and right here we take a look at x squared and x squared again. We notice that we have to multiply by 1. Okay, so I have, of course you have to fill in this as well, 0x plus 0, excuse me, and you multiply x squared by 1, you get x squared. You multiply 0x by 1, you get 0x. You multiply negative 1 by 1, you get negative 1. Again, subtraction, x squared minus x squared, 0. 0x minus 0x, 0. 0 minus negative 1, this is positive 1. Okay, this is positive 1. And this is what we call the quotient. And this is what we call the remainder. Okay, so that means your x to the fourth over x squared minus 1 is the quotient. Right? Take a look at this again. 32 over 5 is quotient plus remainder over 5. Okay, so quotient x squared plus 1 plus remainder over x squared minus 1. Okay, so let's use blue. This is your quotient, then this is your remainder. Okay, now notice that if I want to integrate this fraction, because they are equal to each other, right? So that means I can integrate the right hand side, and x squared plus 1 is easy to integrate. And 1 over x squared plus 1 is a proper rational function. Okay, so this becomes a proper rational function. Okay, so we can perform partial fraction decomposition on this one. Okay, so that's the whole idea. Okay, so what if you have an improper rational function? You need to perform polynomial long division first, okay, to make a proper rational function. Okay, so I will let you do this, practice this on your own. Okay, because eventually you will need to do that on the test, right? So right here we have x squared plus 1, we just copy that, but to perform partial fraction decomposition, you need to factor the denominator, right? Remember? Okay, and then finally you want to solve for the unknowns. So let me give you the answer right here. Okay, x squared minus 1 is reducible. Okay, if you forget, you can check b squared minus 4ac. The discriminant is positive. That means you can factor it. Okay, and the coefficient is negative 1/2 and positive 1/2. Okay, so do this, practice this on your own. Okay, I know it's very convenient to copy the answer. Okay, but on the test, there's nothing for you to copy. Okay, so please make sure that you practice this. Okay, so therefore, if I integrate x to the fourth over x squared minus 1, then I will need to integrate x squared plus 1 minus 1/2 the integral of 1 over x plus 1 plus 1/2 the integral of 1 over x minus 1. Does that make sense? Right? I can, because I have sum. We know the integral of the sum is the sum of the integrals. Right? So integrate this, integrate this, integrate this. Okay? As I said, it should be really easy. The integral of x squared is x cubed over 3. Right? The power rule. The integral of 1 is just x. Now minus 1/2. The integral of 1 over x plus 1 is natural log of absolute value of x plus 1. Okay, and the coefficient is 1, you don't have to worry about anything. And we have 1/2. The integral of 1 over x minus 1 is natural log of absolute value of x minus 1. Again, the coefficient is 1, so you don't have to worry about anything. Okay. Finally, this is an indefinite integral. Okay, I know a lot of students in the past, after they found the antiderivatives, they were very excited. Okay, yeah, I made it. Okay, but don't forget, you have one more thing to do because this is an indefinite integral. You need to put a plus c. Okay, you need to put a plus c. Okay, so in short, if you have an improper if you have an improper rational function, you need to perform polynomial long divisions. Okay, there are more practice problems on Canvas. Please make sure you practice them, and if you have any questions, please do not hesitate to let me know. Thank you.